Previously on Tech Taste.
You're a terrible designer! What was I thinking? It's only gonna fit me! So it seems that we have a bit of an issue here. Well, this is probably the most complicated, intricate, just thing I've ever created of my own design. We have an issue. This fits my finger incredibly well. The reason for that is because I literally built it on my finger. However, the issue comes when one, someone else wants to wear it. Two, if my hands get larger. And I guess three, this does not even fit on this finger. Like, ow, ow, my finger is being impaled by pop rivets. I literally used pop rivets to put this thing together. So, the best solution I saw was I ordered this piece of finger armor to make this one. I just need to make everything. And this time I'm going to make Mark II, and it's gonna be fully adjustable. But before we get to the fully adjustable part, it's best to look at, what was good, what was bad about the first one, because this has now been relegated to prototype. I know in the previous video I said this was the final version, and it would be those issues. And 80% of what you see here is going to be kept, maybe 75. The overall idea is, it's a prototype. I even now made its own little display. That's off topic. So, first issue, one size right here. The best issue as reason I thought of that was to use these things. These are hose clamps, and here we go to tightening. And you just can tighten it up to adjust down to whatever finger size you have. It's seeming like you have to have a pretty large finger, but because we have to clamp around, at this my finger would be squished because there's going to be a layer in between here and my finger, as you'll see in just a minute. And then the other issue is, and this was the main one with RJ, the links. Not everyone's fingers are the same links. So, I'm going to be using this cable and putting little in stops all the way down, little crimps, and you'll be able to pull back a certain number of crimps and tighten down the screw, and they'll work out. I'm keeping the overall embedded flex sensor design, and I'm keeping the little vibrating motors because this is great. As far as the level of feedback you get from this, I mean, using this little bodged together battery thing of a bob, whatever. I mean, just listen to this base motor. Frontal motor. And that one I actually just did there by mistake, which I'm pretty sure what I did there didn't have any real consequences, because the two leads went to two different things. That's the third issue. I don't know the third, I've lost count by now. These get very confusing with all these wires. And so I'd have to build another one of this anyway, because when I was demonstrating this to my uncle on Thanksgiving, I accidentally hooked the batteries up. Instead of to the motor, I hooked them up to the flex sensor. So my mass was almost solving it. Seemed like the most that could have gone through there would be like 1.3 watts, but apparently that's enough to completely fry the flex sensor. So it's kind of fried in that respect. And since I was already planning on building Mark II, there's no need to deal with fixing it, because it's now just going to be on display like Iron Man with his whole Hall of Armors. But the solution to that is to use one single plug. This is a 12-pin plug, which you simply would unscrew this little black piece, solder to the back of here, solder to the back of here, and mount in a terminal. And you run your wires through there, and one plug for the entire finger. And the best part, it only goes in one way. So as long as you solder all the connections correctly, you can never plug one wire and to swap for another. And now, as I said, this has 12 pins. This finger currently has 9 wires coming off it, if you don't count the joystick. Is it 9? I meant 10. The reason for the extra 2 pins is because of yet another small minor issue. The little felt GA thermal module. There's one here you can see. You essentially apply power one way and one side heats, the other side cools. You reverse the polarity, and it reverses which side heats and cools. Although the issue with that is you have to be able to dissipate the heat from the heating side, or else the entire thing just gets hot, which tends to be the issue with this. I'll go to cool, and it'll slightly cool down for a few seconds, and then it'll start to get warm, which is the exact opposite of the effect I'm going for. I believe the issue is this just mess of thermal compound in here. I use this stuff. I bought the cheap stuff. I know you get what you pay for. This thing's probably full of silicone and who knows what else. And then it's not at all a flat connection. It's just this globbiness. So I'm doing 2 further steps with here. One is going to be a direct connection to a copper heatsink, which is then going to be run into this. This is the smallest fan I could find. It should be able to dissipate more than enough heat, and we're fine. I'm also armor coating all the wires just for a little bit of extra durability. But now, as I put Mark I proudly back onto its display, how are we going to make the pieces for Mark II? I mean, these parts are going to have tons of overhangs, and they're really minuscule, and 3 printed plastic just won't really hold up very well with all of this. I mean, I hope for a while. Well, I thought about doing lost PLA casting, but again, trying to get the plaster into all those little nooks and crannies, it just didn't seem practical. So, there's a little thing that I heard about a long time ago, and for a long time I was of the opinion that they were overpriced. But there's a good thing. The smaller your parts, the cheaper it is to do this way, and the smaller the parts, the harder it is for you to do lost PLA casting. And so I went to a little place called Shapeways in New York. Well, I went there virtually. Here, come on, I went virtually, why don't you come virtually with me? Alright, so this is Shapeways. It's a 3D printing company based in New York, and you upload your model and they'll print it for you in pretty much anything you want. Not just plastics like ABS and nylon and PLA, but they'll literally do metals, stainless steel. They just introduced aluminum, gold, platinum, silver, copper, brass, bronze if you are on the pricey side of things, or you want to make jewelry, which I guess you could call this functional jewelry, what I'm making. However, what I did is I went and right here under my orders, you can see that I have actually ordered 2 items, and I'm going to have to block out this information right here, which should ship tomorrow. And what they are these 2 parts. Yes, for those of you who didn't know, I actually have a Thingiverse page. It's simply I keep telling them I'm gonna put Tech Taste, and that's my actual name, James Bryson Smith. But yeah, I just look up Tech Taste to find it. These 2 are the 2 things I had printed. Oh yeah, and the actuator mount and all that is down here. More on this in a bit. The first item right here is a replacement for the PS2 joystick. Let me just show this to you practically, because this I actually could print. Alright, so this is that piece. This was actually printed on the MaRRVE at the University of Memphis, because on my rep wrap I was printing on ABS, and even after smoothing it out with acetone, this is the best quality I could get, which isn't great. It would probably be functional, but it's just not great at all. Actually, I doubt it'll be functional because this piece is so weak right here. So, here is the one printed at the University of Memphis in PLA. I still had to fix the end with a little bit of candle wax. And what this is you take one of these. These are slide potentiometers. I have a whole pack of them off eBay. And you simply pop on the end of it. Listen to this. Kind of like a Lego. And then on the back of it, you will hook this spring, and the spring will, if you put it right, the spring will pull this back when you let go. And here we have this finger again, and we are currently using this PS2 joystick, and you only have to get half range, so I was thinking about actually putting a spring on here initially to pull it back even farther. But instead of doing this, we're going to, and also we're using this much thinner cable. I think it's like 3/64 or something like that. We're going to insert a turnbuckle, which for those of you who don't know is simply just little knurled piece with a left-handed threaded shaft on one side and a right-handed threaded shaft on the other side. And I ordered one of those, actually two of those, and left-handed 3mm tap. I'm going to tap this hole out, screw it in. I screw in one of these little rod in things. It's essentially just like a little ball on here. I know how to show you. Right here. Look at and this, which is a work in progress, is a console printer. I have them right here. These aren't the ones I'm going to be using though. The ones I'm using are actually all matte aluminum, and they're threaded differently on the inside. And essentially what this is. But instead of running a screw through here, you'll be running the cable, and whenever you flex your finger, it'll pull on the cable. And that is one of the two parts I had printed in stainless steel. Let's go back and look at the other part. Okay, now this is the other item right here. And this is the part that accepts the hose clamp. And you just can tighten it up to adjust down to whatever finger size you have. The curvature right here perfectly contours to that of the hose clamp, and the straps go through here. You go into here to adjust the hose clamp with the little ratchet, and this actually all goes on the bottom of your finger in this position. The little vibrating motor fits right down in here, and the wires will come out of here and be covered with the stainless steel wire loom. Little indentation on the other side is for this little pin of the hose clamp to freely rotate, and this design is freely available. This one made more sense to have printed. Actually they both made sense, but this one especially because it would have been almost impossible to print this because they're on a flat surface, so you'll be doing an arc and then internal structure work, and then these free hanging lips. Trying to clean support material out of there would be an absolute nightmare. So yeah, in a few days I should have this in stainless steel in my hand. There's a whole lot more I could say about MaRRVE. I mean, we have a whole week to do that. Tomorrow is going to be something slightly different. It's still MaRRVE related. Yeah, with those things coming from Shapeways, which will probably be before the end of this recording week, the first thing you'll see is a review to see how well they actually perform. Pretty exciting. I just drew something up on the computer, and now, I mean, it's one thing to have 3D print right here, which is incredible, but to actually have it in a metal, yeah, I mean, it just, anyway, hey, yeah, so, for continue updates, as I mentioned in the first video, we have essentially through December the 6th, where I'll be uploading one video a day. And also, as I mentioned in that video, we are going to be voting on the thumbnail. So, I created not one, but 3 possible alternatives. Profile down the corner that you see when you go to my channel. That, well, if you want to keep it as it is, go down in the comments and type keep it. If you want to change it to any of the 3 designs I posted before, go and type change it. If that's not completely clear, you can go back and watch the first video in this playlist. But yeah, I'll see you guys tomorrow.